Hi, this is Miss Wang, and today we are going to talk about the sequences as discrete functions. This is the first lesson that I record myself facing the computer without seeing your lovely faces, which is I really miss, and I enjoy communicating with you every day. But however, this is something new. I really want to try it out. Let's experience together, see how it goes. Okay, let's look at the definition of sequences. What is sequence? Sequence is a list of numbers, so we call it a number sequence. Is a set of numbers, right? A progression of numbers. They are separated by commas, arranged in an order. The order is very, very important, right? So the first term we refer as the t at 1. The first term, right? T of 1 or t at 1, the first term. Second term is as second term t, subscript 2, t at 2, so on. The nth term is t at n. Okay, for example, if my first term t at 1 is 1, okay, second term is 3, third term is 5, fourth term is 7, and then so on. So this dot means that this means that this is a infinite sequence, right? It's infinite. And sometimes you will see sequences like this: 1, 3, separated by comma, 5, 7, and periods. It means that sequence has this sequence has only 4 numbers in it and 4 terms in it, so it's called a finite sequence. It's ending. There is a period at the end. Okay, now we say the 1 is our first term, second term, third term, and the fourth term. They are separated by the commas. Now, so how can we write out the sequence, right? So we know that if we are given a explicit formula, so we can actually write out the sequence. What is explicit formula first? Explicit formula represent any term in a sequence as long as the term number n is given. So the term number is the first, second, third, fourth term. The n, that term number is special. It's only a natural number. It cannot be decimals or fractions. It's just the natural number. Okay, now let's look at an explicit formula example 1. Okay, now let's look at A. I'm going to write out the first 3 terms of the sequence. You are going to write out the other 2. So the explicit of the t and the nth term is given. The nth term equals 3 times n minus 2. That's why we call this is explicit formula. Okay, now if I want to write out the first term, it means my n equals 1. So you substitute n with 1, you get 3 times 1 minus 2, which is 1. So how about my second term? Second term, n equals 2, you substitute n with 2 minus 2 equals 4. Therefore, the third term, you can see that n equals 3 minus 2 is 7. Now, at this moment, I would suggest you to pause, okay, and try to calculate, to write out the fourth term and the fifth term, and then write out all terms for example B and example C, and then pause, and after you finish it, and then compare your answer with mine. Okay, pause please. Okay, now this is the answer. Okay, all of the numbers are listed here. Now the part C, the first term is 1 divided by 1 minus 1 is 1 over 0. The first term in this sequence is actually undefined, which is fine. Okay, now I'm going to you can pause, compare your answer. Now I'm going to move on with example 2. This is our part 2. Okay. Now, let's look at part 2. Part 2 is actually sometimes you are required to find out the explicit formula for the nth term given a sequence. For example, the sequence is given. The sequence is 4, 7, 10, 13, and so on. It's infinite sequence. Now, to write out the explicit formula, basically you have to write out the nth term. So it's the relation between the value and the term number n. For example, the first term is 1. Your second term is 7. The third term is 10. The fourth term is 13. Now, can you see that 4 is your first term, right? 7 is actually 4 plus 3. 10 is actually 7 plus 3. Therefore, 7 is 4 plus 3. It's 4 plus 2 threes. How about 13? It's actually, you can see it's 4 plus how many threes? Plus 3 threes. Plus 3 times, right? Therefore, you can see that the second term, how many threes you add? You add 1 3. Third term, you add 2 threes. Fourth term, you add 3 threes. Therefore, how many threes you added is actually your term number minus 1. Therefore, your nth term will be 4 plus 3. How many threes added? There is n minus 1 threes are added to 4. Therefore, that is your explicit formula. To find out the explicit formula, basically you need to analyze to get your current term, how you are going to adding or subtracting or dividing the previous term to get your next term. What is the pattern? Basically, it's pattern based. Okay, so you got to really look at the connection between the term value. We're talking about term value is 4, 7, 10, and 13, and the value between the term value and the term number, which is 1, 2, 3, 4. Okay, now this is part A. Part B, okay, is use the explicit formula you found it, the nth term. That is, we also call this explicit formula the general term, because it's the nth term, right? The nth term. So the general term, use the explicit formula for the nth term to find out t subscript. This is the 35th term and the 50th term. This is a typo, right? That is just when the printer printed out. It's just changed my format. It should be t, the 35th term and the 50th term. It should be, the index should be smaller. I'm going to find out the 35th term is going to equal 4 plus 3 times 35 minus 1. Therefore, you can see that is 4 times 3 times 34, right? So therefore, it is 106. Now you should pause, calculate your 50th term. Okay, now I'm going to show you the answer. You pause, and I'm going to show you this answer. That is the 50th term. 4 plus how many threes are added is 50 minus 1. Okay, according to that formula is 151. Okay, now we're going to continue for example 3. Okay, example 3, you are given more sequences, so you have to check out the pattern. For example 1 is 4, 16, 64, 256. So you can see that that's your first term. Second term is 4 times 4, 4 times 4, right? Third term is actually 4 times 4 times 4. The last term is the fourth term is 4 times 4 times 4 times 4. Therefore, did you see how many 4s are multiplying there? This actually, there are, for the second term, there are 2 4s. For the third term, there are 3 4s. For the fourth term, there are 4 4s. Therefore, you can write those 4 as 4 to the 2, 4 to the 3, 4 to the 4. Therefore, did you see? Therefore, you can find out the term number is actually the exponent. Therefore, the nth term for the example 1 is 4 to the n. So you can verify, but this case is very straightforward, right? Now, if you look at case 2, is 100, right? Your first term is 100, second term is 10, third term is 1, the fourth term is 0.1. Now, your second term is actually 100 divided by 10, right? Third term is 10 divided by 1. So 100 divided by 10. Now your third term is your previous, it's your second term divided by 10 again is this. How many tens are divided? There are 2 tens, right? Go into 100. 100 divided by 10 twice. And then the fourth term is 100 divided by 10 3 times. Therefore, you can see that the connection between the term number here is one less, how many tens is 1 less than the term number 3 are in the denominator. Therefore, the nth term equals 100 divided by 10 to the, how many tens there? It's 1 less than the term number. So you can verify, actually go back, you can verify for the first term is actually 10 divided by, when n is 1 is 1 minus 1 is 10 to the 0 is actually 1. It is 100. You can verify your explicit formula by checking each term. Okay, now for the third term is going to be, that is 2, 3, 4, 5. You can see that the number is connected with your term number. That's your first term 1. Second term is actually your term number n plus 1, right? You get your coefficient, and then that is your x. It doesn't change, is your variable, and your exponent is actually your term number. Therefore, Tn, your nth term, equals n plus 1 times n to the x to the n. Your example 4, this one is that the number in this sequence is changing positive, negative, positive, negative. It's alternating. How can we model that? And you can put -1 to the n. So when n is your term number is even, right, you will get a negative sign. But look at this even terms, they're actually positive. There is an easy fix. You add 1 or -1. That will change the even exponent, even term number to odd number to even number, right? Therefore, you fix the sign. After that, it's 1 divided by 10. 2 divided by 10 is your term number divided by 10. That is the nth term. Okay, you can pause here, and if you don't understand, can look at this again. Okay, now we are going to move on to the next page. So next page is try to write out the sequences using functions. Okay, I'm going to. Okay, so okay. Can see that this is example 4, using determinate explicit formula in function notation. Now we know function notation, right? So like given your input n, so what is your output? Your output is actually your the nth value, which actually your explicit formula here, right? You want to find out the expression. Therefore, because t at n means that t, the value, depends on the nth value, you can write like this: the term value depends on n. That is also a function notation. So let's look at example 4. The term number is 1, 2, 3, 4. The first term is 7, the second term is 12, third term is 17, fourth term is 22. The first difference, you can see that is 5. So we all know when the first difference is constant, well, it is a linear relation between the term number and the term, right? So any linear relation can be expressed as, the y value could be expressed as mx plus b, right? What is your x? X is actually your nth number, right? mx plus b. For this specific question, your y is actually your term number t of n. So what is m? M is 5. What is x? X is your term number, so plus b. Okay, now how do you solve for b? This is one variable, and you know that you have so many pairs of the term number and the term value here. So when tn is 7, 5 equals 1, you do the substitution, and you can calculate your b is actually 2. Therefore, your nth term equals 5 times n plus 2. N, of course, is a set of the oh, I think you didn't see that. It's a set of the n is set of natural number. Okay, so let's look at your next one. Your next one is actually complicated. Given the term number, the first term is 1, second term is 10, the third term is 25, the fourth term is 46. Now, first difference is 9, 15, and 21. Now, second difference is actually calculated here. Second difference is actually 6, and we know the relation between the term number and the term is actually what? Quadratic, right? Therefore, we can say that any quadratic, did you see we don't know the vertex, we don't know the x-intercept. A general quadratic relation is what? Is y equals ax squared plus bx plus c, right? So this question is a most difficult one, because you have to make connections, right? You have to make, when you see second difference is quadratic, you got to think about quadratic relation between the term value and term number, and then you have to recall quadratic standard form is actually a general standard form is actually ax squared plus bx plus c. For this specific question, what is your x? Actually, your x is your n number. What is your y? Your term, right? So it's tn equals a times n squared plus bn plus c, right? The nth term. Now, how can you find out? If you want to determine the explicit formula, you got to determine a, b, and c's value, right? But how do you determine a, b, c's value? 3 variables. And as we know that in order to determine 3 variables, you need 3 equations. Look at this table. You have so many pairs of the term number and the term value. All of this satisfies this equation, right? So I can say that when the first term is 1, your term number is a times 1 squared plus b times 1 plus c. They satisfy this equation. I got the first equation. Second equation will be second term is 10 equals your n is 2 squared plus b times 2 plus c. Second term. And your third term is 25, actually, when the term number is 3 squared plus b times 3 plus c equals 3. Now we are going to simplify this a little bit, right? So you will get 1 equals a plus b plus c, 10 equals 4a plus 2b plus c, 25 equals 9a plus 3b plus c. How do we solve this one? This is a system of equations, and we know in order to solve system of equations, the method is substitution or elimination, right? And for this one, did you see all of the c's? You can eliminate c first, right? Let's just try it out, because problem solving is that you have something, you can recall something you've learned or make some simple connection, try it out to see whether it leads. If it doesn't work, try another plan. So I think for this question, I'm going to try to eliminate one of the variables, 2 minus 1, I'll get 9 equals, that's 4. 4a minus a is 3a plus b. I get one equation 4. Now I'm going to eliminate another one. How about 3 minus 2? Right? I want to keep all of the coefficient positive, right? 25 minus 10 is 15 equals 9a minus 4 is 5a plus b. Oh, I got another equation. Look at it here. Well, it seems quite, eye-pleasing because I can see b and b. If I try to keep eliminating, I will solve for a. Therefore, how about 5 minus 4? I eliminated b. I got 2a equals what? 6. Oh, I get my a's value. It seems this elimination method works. Of course. Okay, after this, I find out my a. I will substitute a equation a equals 3 to one of these two equations. Of course, I'm going to use this simple equation with a lower value of the coefficient to 4. I get 9 equals 3 times 3 plus b. Hey, b equals 0. Once I get b equals 0, I can easily solve for what? C by substitute 6 and 7 to what? To equation 1. I will get 1 equals a equals 3 plus 0 plus c. Therefore, c equals negative 2. Wow, done. Therefore, once you find a, b, c, your nth term equals a equals 3n squared plus b times 0, right? That's 0 minus 2. That is your formula. And n is natural number, which means that this is a discrete formula, means that your n cannot be any real number. It's all the points, right? All the points. You can have to list those numbers. Okay, so that is the end of our lesson. And you can, if you don't understand anything, you can go back, listen again, and tomorrow when you're in a class, you're going to work on the homework. I can help you. Thank you. Good night.